Welcome, everyone. I'm going to present the progress we got with the GraphQL implementation. This work started on the past summit in Berlin. At that moment, we was discussing how we can improve the scalability and simplify the code and things like that. And we considered that GraphQL could be an option for this, and we are now implementing, migrating some components to validate the results and things like that. Okay. So first, I'm going to present the reasoning why GraphQL is being considered as a solution. So Meteor, that's the component that is providing data for the browser. Currently, it runs in Node.js, and Node.js is limited to one CPU core. So no matter how big is the server, it will not scale. We implemented some ways to attempt to scale it, like running multiple meters and things like that, but this duplicates too much work on the server. So it scales, but at a high hardware cost. So we want to search for alternatives. And GraphQL is a standard way of consuming data. So now Meteor is only providing data to the browser, but with GraphQL, we will be able to open the BigBlueButton data for different devices. So we can have IoT devices, we can have second and third screens like a tablet, smartwatch, things like that, connected directly to BigBlueButton and getting information. And it's bandwidth efficient. So we can provide server-side aggregations like the count of the users. This is not possible with Meteor and Mongo. Server-side pagination, same thing. And we can get a subset of an object. So let's say a component wants only specific fields of an entity. It's up to the client to define which fields are going to be consumed. So the browser is not going to receive more information that is needed. It's also reactive, but only for what is currently displayed. So I'm going to present it later, a demo, but basically, if you are on the top of the user list and the users are joining, you will get information up to the users that fit in the user list, and everything that happens outside the screen is not going to be transmitted. So it saves bandwidth. So Hasura is the server, the GraphQL server we choose for implementing GraphQL. For now, it's the solution that we're going to use, but it's a GraphQL server. We can always replace it by something different if we find that it's needed. It's a standard, so it's better than Meteor, because Meteor is one solution. We cannot replace Meteor because it's not using a standard way to communicate with the browsers, but GraphQL is a standard. So we're not willing to replace Hasura, but we can replace if it shows problems. And Hasura has a low learning curve, good documentation, scalability. It also provides the server-side filtering that's important for the security. And it also has an interesting feature, that's the query multiplexing. So if several browsers are looking to the same data, this data will, one query is going to be performed to database is sent to multiple browsers. So it uses resources in a wise way, let's say. So in the initial architecture, we considered that Akka BBB apps could feed Postgres with data, and Hasura would consume data from Postgres. It works. It worked in the previous summit, but then we found some challenges. To multiplex the queries, they need to use the same filter. So if we want to limit what the user can see, it's much better to talk to Hasura that we want to get, like, the query will return this result for a viewer and this result for a moderator instead of the specific user ID because of the multiplexing. So we wrote all the queries. Gustavo's not talking, but he did most of this work. So I'm just presenting here. But we specified the queries in a way to use the role of the user. But the role of the user is provided to Hasura when the browser connects. So browser connects to Hasura. Hasura asks BBBWeb what is the current role of this user. BBBWeb returns. But in BigBlueButton, you can modify the role of the user. And so Hasura, there is no way to update this session variable that's attached to the connection. So we had to add this extra components, that is the GraphQL middleware. It basically opens, browser connects to the middleware, middleware connects to Hasura. And middleware is listening to Redis messages. So BBB apps can say, okay, this user is now this user is now invalidated. So the GraphQL middleware will kill the connection with Hasura while preserving the browser connected, and it will reconnect. So when it reconnects, it will get the current role of the user. Information is going to be sent back to the browser, and everything works. So we could, and without adding any reconnection on the client side. So it works. We need to hurry up because I almost use it all the time, and we have several people to present. So I'm going to skip some slides here. So who's going to present the who's typing? Me. Okay. Go ahead. I will make you a presenter.
Okay. So one of the benefits of using GraphQL is removing a lot of complexity from the code needed to fetch data from the client. Because of the server-side filtering that Tiago mentioned, the logic to check which parts of the information each user has access is moved to Hasura. So it's now much easier to do it. Here I will show the code for the type indicator before and the code that is needed with GraphQL. This is the code without GraphQL. And this is with GraphQL. So it was simpler to do it. And this is a GraphQL query that we use to that. Is it so now userless?
Okay. So can you make a presentation? Okay, so we have a video recorded here, and it shows on the bottom we can see the Meteor BigBlueButton, and here the GraphQL BigBlueButton, and we are joining several users. We can see that here on the top, once the user list is full, no extra data is being received by the client. But here, even that the users are not displayed in the user list, the data is, the client is getting flooded with all this information, and this information is persisted in memory. So here the BigBlueButton with GraphQL is just resting, just the number of users is updating, and here everything is getting re-rendered all the time. So it's much better in terms of performance and in terms of memory also. And the video continues, but this is what we want to show. As you can see, it's stopped here. Nothing is going, nothing is flowing in the WebSocket, but here it's flooded with information. We can do more extensive demos in near future because of the time. Okay. Chat list.
Okay, so basically I would like to call your attention to the chat list because it's normally a component that we don't see too much. It's on the top left corner of the user interface. So this is the query I use to fetch the data. You see that the query is updated every time the data is updated to. This is the result I get when the query gets to the front end. Here I put the mutation. So the mutation is going to change the data directly from the front end. So we don't have to pass through the archives component. Here is a benefit of the TypeScript that we are using in this GraphQL implementation. Some of the types I used to in the implementation of the chat list. That's pretty much it.
Chat, Tainan, make an presenter.
Okay, guys. About the chat. That one's the chat. I think everyone knows it. The main change we're using GraphQL is in the query we use a pagination to make just load the data in the screen. So instead of we get every message in memory like in the Meteor run, now the client just fed a small chunk of data. We made a pattern for when the user is tail the chat, when it's in the bottom just following the new message. In the tail we just get a fifth message. So everyone that is using the tail of the chat will keep with the same query. So we use the benefits of multiplex. Also, the user list has it, but Tiago didn't mention it. And I think that's it for my part.
One important part, please go back, and
Okay.
is that for each chat message, we get the name of the user, the message, everything included in the message that the server is sending. So basically, the chat component does not depend on other components, and this is really, really important and a big benefit of this implementation. Okay, go ahead.
I think that one was left over.
Okay, go ahead.
Né? A gente está no último. So, about the who is talking component. Those are the queries I used. As you can see, very simple stuff, and also very used to do with GraphQL. To fetch some very simple data from the users. So what is the who is talking component? The who is talking component is the one that shows how many people and who is talking, and exactly how does it do it. So it fetches some information from our database, and now we are fetching this data using GraphQL, and it catches all the important information to do that, and then it's passed to the front end, and we can see it in the client. Future word.
Okay. Can you make myself presenter again?
Yes.
Okay, so as future work, well, we need to finish migrating the components, making sure no feature was left behind. Like we know some stuff was not migrated yet in the components we showed you. We need to create some kind of CPU and memory profiling of the middleware, just to be sure it will scale fine. And also configure some kind of HA, because the middleware does not keep any state, so it can run like 2 or 3 instances. If it crashes, it just continue working. In BVB apps, we need to ensure that all events are correctly persisted, and also ensure that it's written in the correct order, so things don't get messed on high traffic. And well, this is a work in progress. It's the kind of watchOS application that's going to vibrate when someone raises hands when you are using the Apple Watch, things like that. Yeah. So I think we're not going to demo now because there are other presentations to come. But if time permits, after the other presentations, we are going to get back and show the demo of this thing working and answer questions. We, of course, underestimated the time we would need for this presentation because we already exploded the time. So thank you very much. And we had a testing presentation that maybe we can. Is it included on this time or no? Go ahead. You can. Okay, you can do it. So let's continue to the testing presentation.